Hello guys, in today's video we are going to discuss the solution of the problem construct binary tree from in-order and post-order. So let us look at the problem statement. The problem statement says that given in-order and post-order traversal of a binary tree having n nodes in the arrays in and post respectively, the task is to construct a binary tree from these traversal. Driver code will print the pre-order traversal of the constructed tree. So for instance, in this example, n equals to 8 is given to us. In-order and post-order traversal of the binary trees are given to us. Now using this in-order and post-order traversal, if we construct the binary tree will look something like this. And the pre-order traversal of the binary tree is 1, 2, 4, 8, 5, 3, 6 and 7, which is what is our output. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So in order to discuss the solution of this problem, let us take an example. Let us say the number of nodes which we have is 8 and the in-order and post-order traversal which is given to us is this. Now let us see using in-order and post-order traversal how we will be able to construct a binary tree. So since we know that in a post-order traversal, the last element, which is this, is the root of the tree. So this becomes the root of the tree. So 1 becomes our root of the tree. Now what we are going to do is we are going to search 1 in the in-order traversal. So in in-order traversal, 1 comes over here. This simply means that this portion is the left side of the binary tree and this is the right side of the binary tree. So let us do that. So the left side of the binary tree will be 4, 8, 2 and 5 and the right side of the binary tree will be 6, 3 and 7. After consuming element 1, we are going to take that element out of the post order traversal. Now the next element is 3. So since 3 is the next element and since this is a post order traversal, so remember the post order traversal is left will be first, then right and then the root node. And since we are iterating the array backwards, so the first element which we observed is the root. The next element we will see is the right part of the binary tree. 3 will be in the right part of the binary tree. So 3 is over here. So what will happen is 3 becomes the root of the binary tree and then the left and the right child will be 6 and 7. So 3 we have consumed it. Now comes 7. So 7 becomes our right part of the binary tree and 6 becomes our left part of the binary tree. After that, the next element is 2 and 2 will be in the left side of the binary tree and 2 is this element. Now since 2 is this element, so the left side of the binary tree will be 4 and 8 and the right side of the binary tree will be 5. Now the next element is 5, which simply means that the right side of the binary tree will be 5 and this will be my next element. After 5, the next element is 4, so that simply means 4 will be my left side of the binary tree and this is my 4. And see over here, towards the left side of 4 there is nothing, because of which the left child of the binary tree will be none, whereas the right side of the binary tree will be 8. So in this way, using in-order and post-order traversal, we will be able to construct our binary tree. Now let us discuss the pseudocode for this approach. So let us say we want to build a binary tree and in-order and post-order traversal is given to us and the size of the array is given to us. So the first thing which we are going to check is whether this is an empty list. If this is an empty list, that simply means that it is a empty tree, because of which we are returning none. Otherwise, as we know that the last element of the post order traversal is the root node, so let us take that data. So data is equals to the last element of the post order traversal. So what we are going to do is we are going to pop that last element from the post order. So let us do that. Once we have done that, let us create a root node. So root is equals to node data. In this way, a root node has been created whose left and right child is none. So now, as we have discussed in our solution, once we have identified our root node, the next thing which we were doing is that we were searching that root node in our Inorder traversal. So let us search that root node, or rather the data in the Inorder traversal. So in this way, we will be able to do a linear search and we will be able to find out the index corresponding to data in Inorder traversal. Once we have this, now let us populate our right and left child. So let us populate our right child first, since we are traversing the post order traversal from end to start, because of which we have to populate our right child first. So the right will be equals to buildTree. And now let us see what should be our Inorder, Postorder and end. So as we have discussed over here, if this is the index, then the right tree contains only these elements. So if this is my I, then the right side of the tree will be in the range I plus 1 to n, and that is what we are going to use. So within Inorder, it will be I plus 1 all the way till n, and the post order and n remains as it is. Please note, we are popping an value from the post order, because of which the post order size is getting shrink. Similarly, the left side now, so root.left is equals to buildTree and then the Inorder. So just like in the right side, the Inorder varies from I plus 1 to n, over here the Inorder varies from 0 to I, and then post order and n. And once we have populated our left and right child, we are going to return root. And in this way, we will be able to construct a binary tree. So that's about the pseudo code, folks. Now let us see how we have implemented it in Python. So the implementation is pretty much the same as what we have discussed. If n equals to 0, that simply means it's an empty tree and we are returning none. Otherwise, we are constructing the tree and then we are returning root. In construct tree, if Inorder or post order becomes 0, or it becomes an empty list, then we are returning none. Otherwise, the data is something which we are popping from the post order. We are creating a root node and then we are finding out the index of data in the Inorder list. Once we have the value of I, we are populating our right and left child and then we are returning root. So that's about the code, folks. Now let us submit our solution. So our solution got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.